So again, we're going to be talking about managing secrets across multiple clouds using HashiCorp Vault. So what is HashiCorp Vault? So Vault is a centralized secrets management platform. The objective of Vault is to access secret data in a way that's flexible, secure, and scalable. So why should you care about this? Why should you care about HashiCorp Vault? Well, HashiCorp Vault improves your security posture. It mitigates risks, and it improves application development velocity by making it easier to integrate secret sharing into your applications and workflows. Just as a personal story, when I was a new developer, secrets used to scare me. They would scare the daylights out of me. And the reason why is because the workflows around secrets management were pretty much opaque. And they were opaque in the best case scenario. In the worst case scenario, secrets didn't even exist. There was one time where I worked for a big telecom company or was contracting at a big telecom company, and somebody, a co-developer, literally whispered a secret into my ear. The production database secret was whispered into my ear. There was another time where I was contracting at a big defense contractor, and there was a security breach. The attackers actually got a hold of a security token that was being passed around via email. So these are some of the things that HashiCorp Vault can help with by centralizing your secrets, by giving you a clear, defined workflow. But let's talk a little bit about how HashiCorp Vault came to be. Well, let's say in the past, our systems used to live behind a firewall. They were all co-located behind a well-defined security perimeter. However, our systems don't really look like that anymore. Our data centers are distributed literally amongst the clouds. When that happens, all of our individual applications, all of our individual machines that are running our systems need to be locked down. And if you lock something down, then of course you're going to need many keys to open those things when you need them. Now we're talking about multiple identities. We're talking about multiple network topologies. We're talking about multiple systems defining their own security rules. And there's really no centralized way to manage that unless you use something like HashiCorp Vault that manages all the details for you so that you can have one coherent view of your security policies and your secrets management. So let's talk about how HashiCorp Vault actually works. So we just talked about there's many different ways to achieve things when we start to spread secrets management across clouds. When we start to talk about identity management across different platforms and vendors. Well, the way HashiCorp Vault works is we choose one of the tools that we were already using to establish identity. For example, you may be using Okta as an identity management tool. You might actually be using GitHub. I mean, a lot of us have gone to websites that say, hey, sign in with GitHub. GitHub, we trust GitHub's identity. So with HashiCorp Vault, what you can do is log into Vault, or you can authenticate with Vault using what we call an authentication backend. And that authentication backend could be something that you're already using. For example, GitHub, Okta, AWS, IAM. These are the things that you can use to authenticate with Vault. Once you're authenticated with Vault, what you're going to do is you're going to ask Vault, hey, Vault, I need keys to access some services that I have on AWS. I need keys to access my database. I need keys to access some infrastructure, maybe queue. So those are two different ideas. One idea is that I need to authenticate with Vault. So now Vault is the master of all things secret. And I authenticate with Vault. And then I ask Vault for permission to go access one of my third-party tools that might be out there in the cloud, or one of the services that I actually spun up and placed in the cloud. So that's pretty much how Vault works. Just as a recap, we have to authenticate with Vault. The ways we do that is with identity providers such as Okta, SSH, AWS IAM, GCP, what have you. Once we're authenticated with Vault, we can ask Vault for the permission to access some of our applications that we might have out there. Accessing applications is what we call secrets engines. So I might have a database secrets engine that interacts with Postgres or MongoDB or AWS or Oracle. And that's pretty much the picture of how Vault works. In summary, a client authenticates with Vault. Once authenticated, that client will ask Vault for secrets, for keys to a system that it needs to interact with. And Vault will return a token giving the client capabilities to interact with that environment. So let's jump right in. This is a kind of a code-based conference. And so we'll jump right in and start hacking on some code. So let's see what we got up here. All right, this is me. Let's see. It looks like we got Vault running already. One of the things I like to do is monitor my TCP connection. So I like to monitor my TCP connection so we can see how we're interacting with Vault. And what we want to do is we want to check to see if Vault is, if Vault is okay. Cool. So the first thing you want to do when you're working with Vault is you want to check to see if Vault is okay. So the Vault server is up and running in this tab, and we checked with our clients in another tab to see if Vault is up and running. We can see that Vault is a API-driven system. So even though we're using the command line here and it looks like we're just launching commands from the command line, in the background we can see that TCP requests are being made. Already we've actually made 2 TCP requests to the Vault client, the Vault server. So the first thing that I want to show is I just want to get the audience a little bit familiar with how Vault works. So let's imagine that you're building an application and that application wants to store key value pairs, secret key value pairs for its users. Now, I once worked at a large CI/CD company, and that CI/CD company would store environment variables for people who want to run their CI/CD processes. I worked for another company that wanted to secretly secure usernames and passwords. In both cases, HashiCorp Vault could be of utility. Let's see how HashiCorp Vault might handle that. So in HashiCorp Vault, what we have is, like we mentioned before, is we have secrets engines. So let's go ahead and list our secrets engines. So as we can see, the secrets engines we have a key value system. Now, key value systems sound very good for storing key value pair data, like, for example, secret environment variables. So without going any further about why we might need a key value engine, let's go ahead and try to use it. So Vault is a very path-based system. So Vault is saying that if you want to use the key value engine, everything you use is going to be connected to a secrets path, a path called secret. So what does that mean? Let's actually store a secret. So I can say Vault KV put, and I want to put a secret at the path secret data, let's say greeting. In greeting, let's see what key value pair we want. Maybe we can say greeting equals hello world. So now we have a secret stored in our secrets engine. So let's go ahead and get Vault to retrieve that secret. Okay, so now we can see that Vault is able to store our secrets for us. Now, why is this sort of different than, I don't know, any other key value store? Well, while we're just storing, key values in sort of a database, Vault is encrypting these key values for us at rest. And when I'm across, the other side of the United States accessing these secrets, they're being transmitted to me in route encrypted as well. So Vault stores your secrets encrypted at rest, and it also encrypts your secrets in transit. So you can be sure with Vault that you're actually getting, a full scope of encryption and a full scope of privacy. So that's great. So let's talk a little bit more about secrets, key value, and let's move on to authentication. One thing that I do want to show is that even though we're using the command line, Vault does have, let's see, what port was it on? 210. Okay, so Vault does have a user interface, a very lightweight user interface. A more fleshed out user interface is coming along shortly, but Vault does have a user interface. If we went to the secrets, we can see the secret that I just created in our user interface. If I wanted to create a new secret or a new version, I could do that here. So for example, let me go back out to secrets. Let me create a new secret. I can call it secret. The path can be data secret 2, and I can call it new secret. And there you have it. I created a new secret at the same path of data. All right. So the next thing we want to do is talk about identity. That's the next major feature that Vault provides, is identity management. So what I'm going to do here is I'm going to actually show you how to make some quick identity. So when you, as we spoke about before, when you're actually accessing Vault, you actually have to identify yourself with Vault. Now, right now, we're using the root account with Vault. The root account has all the capability that Vault can possibly have. It's an admin account. What we want to do is show how we can create identity or an account for different users. And the simplest way to do that is probably with a simple username and password. Now, just like when you're using secrets and you want to list your secrets engines, you can also list your authentication backends. Forgive me. Right now, we just have a token-based authentication backend. Basically, if you have a token, for example, I have the root token, I can log into Vault with my root token. However, we're going to use a different authentication backend here. We're going to use a user password authentication backend. So I want to enable this particular backend. So now if I go ahead and I list my auth backends again, you can see that I just enabled the user path authentication backend. And this is the most simple, which is why we're going over it first. The next thing we want to do is we actually want to talk about policies. Before we actually make a user pass another user, we want to talk about what that user can actually do within our system. So let's take a look at a pre-made policy that I created in the past. So I'm going to cat user. So as you can see, I have a very simple policy that says the user that I'm about to create can only read from this particular path. We spoke about before that Vault is a very path-based system. So everything's based on paths. So I'm actually, like a file system, telling Vault that any user who has this policy can only read from this particular path. So let's go ahead and tell Vault about this policy. And the way you do that is with Vault policy write. And I'm going to call that policy user. And I'm going to say that policy is user policy .htl. HTL being the HashiCorp configuration language. So I just wrote a policy to Vault. the next thing I want to do is I actually want to create the user. So I'll say vault right, and I'll say auth user pass, which is the path to my user path authentication backend endpoint. What I want to do is I want to create a new user, and I'm going to call that user me, Eric J. And I'm going to have to provide a password, which I'm just going to call pass, and I'm going to have to provide some policies. And those policies, that policy is just going to be the user policy we have just created. So if everything's okay, I'll actually get to create my user. And so once you have a user with a password, the next thing you want to do with Vault is actually log in with that user. So I'm going to log into Vault. I'm going to tell Vault that the method I want to use is actually user pass. And the next thing I'll do is provide my username and password. So let's say username equals me, and my password is that password that I had just created. Now what Vault is going to do is Vault says, hey, you had a username and password, now I trust your identity. I trust your identity such that I'm going to give you a token. And you can actually we can actually store this token away. So I can say my user token. Let's go ahead and paste that token in there. And that's great. So if we go back to our policy, we saw that our policy gave us the ability to read from a particular path. And so I should be able to, as this new user who just logged into Vault, I should be able to read that key value pair. So let's go ahead and Vault KV get. And I think that was that secret data reading. I should be able to read that. And I was able to read it. So my new user was actually able to do that. However, if we look back at our policy, we can see that, if we look back at our policy, we can see that this user was never intended to write to that path. It could only read. And therefore, what we can do is we can go verify this by trying to actually write something as that user. So let's do vault put, and I'm going to try to put something at secret data reading. Maybe I'll try to update the same, key value pair, and I'll say that greeting now equals hello world again. And as you can see, Vault honored my permission or my policy, and it says that the permissions were denied. So what did we see here? We saw that we used a very simple username password authentication mechanism, and we were able to access some data that we actually stored with Vault's key value store. And we saw that Vault actually honors the permissions or policies that we put in place. So that's great. But to tell you the truth, it's a little mundane, I understand. So let's take a look at another authentication method that might be a little bit more interesting. And that authentication method is going to be the GitHub authentication method. So for example, if you're making an application, or you want applications to talk to each other, and you want them to use GitHub identities rather than user passwords, let's talk about how that might be done. So without further ado, let's go into that. And Mac, if there's any questions popping up in the, you can interrupt me and ask those questions. So what we're going to do here is we're going to go and we're going to do our GitHub workflow. All right, so let's take a look at our auth methods again. Excuse me. Let me log back in as the admin user. Vault login root. I'm back at root, and I can say vault list, and we can see that we have enabled the token auth backend and the user paths auth backend. The next thing we want to do is we would like to enable the GitHub backend. And now we can see that the GitHub backend is now enabled. The first thing that we want to do with GitHub is we want to go identify a GitHub user that we would like to be able to access Vault. We could also identify a team, but for simplicity's sake, we'll just use a user. So I'm going to go out to GitHub. Let's see, github.com. And here's me. I'm already logged in. This is my user. Here's my username and just my profile. As you can see, I'm a part of an organization which is called Security Team in-house. We're going to need some of that when we're interacting with Vault. So let's see what we do with Vault to get it to authenticate using our GitHub profile. The first thing we want to do is I want to tell Vault about my organization. So I'll say Vault right, auth, GitHub. That's the path. Again, Vault is very path-based. I would like to tell it that I want to configure GitHub, and we want to tell it the organization is that security team in-house organization that I belong to. And Vault is going to say, okay, now I know about the organization. The next thing we want to do is we'd like to tell Vault about my actual user. So actually, I want to map a Vault user, create a Vault user, and we're going to give it that same policy, that same user policy that we had before. So what I'm doing here is I'm telling Vault, create a user called basically me, and map a Vault user, map a GitHub user to Vault and give it this policy. So that's what we're saying here. So I'll go ahead and do that, and everything's okay. Then now I have a Vault user. So how do I log into Vault with this user? Well, you have to get a GitHub API key. Now I'm not going to step through how to get a GitHub API key. Basically, you just go to GitHub and you click on API key, and it will generate an API key for you. But I can tell you that I think I have one already. So let's see what I have here. Address. I do have a GitHub token. And so what I can do is I can do Vault, login, and in this case, the method is going to be GitHub. And I think the syntax is token, and you just, I can just say Vault token. GitHub token, forgive me. Let me see, where's my token? Let me echo out this GitHub token. All right, that's my GitHub token. Bad token. All right, let's go create a new token in GitHub. Hopefully I can get this to work. Live demos. Let's see. Go to things. I believe I can get token. Where is getting a token?
So while you're doing that, I'm gonna the question from Rodney Jackson, and I can answer it. So you can go ahead and do that. Would you recommend that developers use Vault in their lower environments as well as production? We tend to see devs use environment variables in lower environments, which is better than hard coding for sure, which also unfortunately happens at times. So I'll answer. You can add to it in a bit. So basically, what we typically see for people who are using Vault is we like to see people use the same workflow that they use in development and testing and production, just because it becomes kind of weird, right? Because what happens is that when you start like putting things in environment variables in dev, and then you're doing something different in testing and production. There's situations where maybe things don't propagate properly or they're not tested properly. And when it gets to the higher environment, so things that worked in development and testing doesn't work in prod properly. I'm talking about going to Vault and getting the secret, for example, right? Something may not be happening. So we like to see people use the same workflow that they would in all the different environments. And here goes another one so tell me when you're ready, Eric. I'm just going to keep going. There's one more question here. Is it possible to have a centralized production Vault server in a local Vault dev server and be able to sync the secrets from a production server to a local dev server? So I'm assuming, yeah, you can have a centralized production Vault server. So let me answer this question. So Vault has two versions. It has the open source version and they have the enterprise version. In the enterprise version, you have the ability of doing, I guess you could say you can be able to sync, but I don't know that's the best way. What I would do in the enterprise version of Vault, they have a concept of namespaces. So in that, use basically a namespace is a vault within a vault. So you can have multiple Vault instances. So you would have a namespace for development, and then all of your development activity would go against that namespace, and then you would have one in production. Now, I mean, you still have the situation of like moving the secrets over or copying them over, but they're just API calls at that point. You can have a script that moves them over, or you can just have one central vault, and you can use policies to specify. Like you can have different paths, like Eric showed. You can have one path for development and one for production. And all you're doing when you move from dev to production, you're changing the path. So you'll have a secret A that's in the dev path, and then you'll have secret B that's in another path for production. So Eric, I'll turn it back over to you.
Wonderful. And just on to that last question, I would also sort of question why production secrets would actually, you would want to sync your production secrets over to development. Sometimes those secrets can be anything from, I know it depends on the environment, but that secrets can be, for example, health data. In the past, I used to work at a large health provider. This was Philips up in upstate New York. And one of the things we would do is we would go through great deals of trouble trying to remove data, health data from different applications, from different docs that the researchers would use. And basically kind of transferring that information over to a dev server where the developers would actually, mistakenly could access this data was really kind of a no-no. So if that's the situation that, I just want to transfer over some data so that I can use it to develop, It might not be the best idea to get that information from the production environment. That's just a heads up. I know it didn't have too much to do with Vault. But in any case, what happened when we were working on is that I was trying to authenticate using GitHub, but the token was wrong. So I generated a new token, and now you can see this token. I'm going to delete it anyway. But now we have a new token, and we've actually were able to authenticate using our GitHub authentication method. So here we've actually displayed a different authentication method. If we actually go back to the slides here, we could see that we have multiple sources of identity, or with Vault, we can use multiple sources of identity. And one of them is actually GitHub. Again, we can go on with this, or we can go on with that theme, and I can show you how you might be able to use Okta. We can show you how you might be able to use AWS to authenticate. But the key here is that we want to make Vault flexible. Vault has to be flexible. It has to work with the authentication mechanisms that the user feels comfortable with. We have to work with the authentication mechanisms that might already exist in a given environment. And therefore, we have to be a little bit flexible about what we consider to be a trusted source of identity. And so in this case, we showed vanilla user password, and we also shown that we can authenticate with a GitHub identity. Now going back, I'm logged in as a GitHub user. And with this GitHub user, I gave the same policy. As we can see here, I gave the same policy that I had given my user password user. And so therefore, we should be able to do a vault get or vault KV. We should be able to get that same secret data that was living at the greeting path. And we're able to do that. Great. So what should we show next? So I think I have one more trick up my sleeve. And what I'm going to show you is one of the best use cases or major use cases for HashiCorp Vault. Now, there are, let me see, what's the best way to put this? So applications, when they're accessing a resource, they only need to access the resource for the time that they actually need to access that resource. For example, if I'm an application or an actual user reaching out to a database to retrieve some data, I only need access to the database for the amount of time that it takes me to complete my task. And this is the best security policy. I shouldn't have credentials just kind of lying around waiting for someone to get a hold of those credentials so they can access my database anytime they want it. In fact, I used to work on applications. I remember one Rails application where there was basically a long-lived secret for the database. Any part of the application, and Rails applications and monolith applications can get very large. Any part of that application could access any part of the database. And there was one database password, and that database password lived forever. So instead of having long-lived database secrets, Vault gives us an easy capability to create short-lived database secrets. And let's go ahead and demonstrate that. So what I'm going to show you in Vault is called dynamic database secrets. And so what we're going to do, if we're going to use dynamic-based database secrets, we're going to have to start up a database. So let me just do that. So, I'm hoping that's the right command. And it's starting up Postgres.
So while that's happening, Andrew Cameron was like, is it a common practice to secure access to Vault with tools like Beyond Trust or CyberArk?
Are you talking about, are there authentication backends for tools like Beyond Trust or CyberArk? The answer is, so if those tools provide some form of identity, then an authentication backend can be made to authenticate with HashiCorp Vault. So HashiCorp Vault gives you the ability to implement authentication backends that you can basically add to HashiCorp Vault if they don't already exist. What we're actually looking for is a strong identity provider, a strong authentication mechanism. Now, if these tools that you're using are popular, perhaps they actually already exist for HashiCorp Vault. But if not, HashiCorp does provide a way for you to implement those authentication backends by implementing a well-defined interface yourself.
And I'll add on to that. So I think Beyond Trust and CyberArk are usually look at HashiCorp Vault as a competitor. So I think we've tried reaching out to Beyond Trust, I think for sure, to try and work with them in the past, but I don't think they've been so open to work with us for a number of reasons.
So you mean that we reached out to try to create that authentication backend, but no luck?
Yeah, I don't think they really want to open up their authentication mechanism to Vault. So I think that's been the real didn't really see them as a competitor. Oh yeah, for sure. Andrew was just yeah, for sure. Like CyberArk for sure, because CyberArk has something called Conjure. Conjure is like it's like a plug. It's like another. I don't know. It's like their version of Vault. That kind of bolts on the CyberArk. So they kind of see us as a competitor, unfortunately. So I'm sorry. I'll just do that out. I just wanted to add a little tidbit there. So I'm sorry. Go ahead, Eric.
All right. So I know we're brushing up against time here. I want to leave some time for a discussion at the end. So let's go through this. So what I'm going to do is I conveniently have, now it's a little bit verby to set up a dynamic database secrets engine. So I just want to go and I want to, maybe show how that's done with predefined scripts. So let's go ahead and move over to my DB demo and let's see what I have sitting here. So the first thing I want to do, or these scripts pretty much define the workflow that you'll go through when you're setting up a dynamic database secrets engine with Vault. And what that is the first thing you want to do is enable the DB backend like we've been doing. So let's go ahead and do that. Let's go again. We're getting the hang of this. We want to go and enable the database backend. Excuse me. What did I do here? Oh yes, that's right. I gotta go back in as root. I'm logged into Vault as my GitHub user, so I want to log back in using my root token, which is just root. So the first thing I want to do is I want to enable my secrets backend. We want to enable the database backend. Okay, and we can go see that that's available now. So now we're building up the secrets backends we have available, and one of them is database. The next thing we want to do is configure our DB. Now, I could go in and type all of this, but I guess we're not here for an exercise in typing, so I'll go ahead and I'll source this file. Excuse me. And I'll go ahead and run this bash command that I've created. So what this bash command is going to do is it's actually going to configure our database. It'll go ahead and write our database configuration. It'll say, hey, make a user for me. And say that the plugin that we're going to use, or the database, the exact database that we're going to use, is we're going to use the PostgreSQL database. Now I'm going to say, what are the allowed roles? This is really saying, what's the name of the database that you're going to use? Like, what's the name of the database that you just created in Vault, not the name of the database in Postgres. Then it's going to make a nice connection string. Vault, just like anyone else, needs to know how to connect to the database, and then we're going to use a simple username password for that database. It needs to know the username and password for that database to kind of plug it into our connection string. So that's how we configure our database. So if I go ahead and I run that command, configure db, with any luck that'll work, and it did. So we went ahead and we configured our database. Now the next part is key to what we're actually doing. The next part is actually telling Vault how to actually give us back credentials for our database and what access those credentials have. So as we talked about in the beginning, anytime we make an authentication backend, anytime we authenticate with Vault, the reason why we are authenticating with Vault is so that Vault can give us, so we have access to ask Vault for credentials to operate some other system. And that's what we're doing most of the time. Sometimes we're using the Vault KV secrets backend, and what we want to do is we just want to authenticate and use that KV secrets backend. But a lot of times what we're doing is we're trying to get access to some other third-party system. Like, for example, I'm actually authenticating with Vault so that Vault can give me keys so I can use a service in AWS. So that's what we're doing here. We're actually authenticating with Vault so that Vault can give us access to our database. But first, we have to tell Vault that when it gives us keys, we're asking Vault, hey, Vault, when you give me keys, what access does those keys have? Like, what can I do with those keys? And in this case, we're telling, hey, your keys are for a Postgres database, and what you can do with that Postgres database is you'll have access to all the tables in my public schema. And so that's what this creation statement says here. If I change this SQL query to say, hey, only have access to these, 4 or 5 tables, then I'll get back keys to give me access to only those tables. So what I'm going to do is I'm going to go ahead and run this map credentials creation function, and Vault will say success, and we actually have access to ask Vault to create some credentials. And let's see. And so that's pretty much it. So what we showed were basically just a series of workflows that help you get up off the ground with Vault, and basically how to manage secrets in a pretty much dynamic environment. Now, one thing I do want to mention is that we really didn't discuss where Vault was actually deployed. We didn't discuss whether Vault was deployed in a container. We didn't say Vault has to be deployed on a VM. We didn't talk about Vault has any dependency on any individual cloud provider. And that is very purposeful. The reason why we said this is because we wanted to store Vault anywhere so that we can manage secrets anywhere. And that's one of the main basically strengths of Vault, is that you get identity management and secrets management in any environment that you happen to be working in. And not only that, you can use it with any authentication backend that you might already have. And you can use it to manage the secrets for any system that you might be using either predefined secrets engines or secrets engines that you create yourself. So thank you for participating in the session, and maybe I'll turn it over for questions and answers.